All right, guys, so I just wanted to go over all three of the forms in a little bit more detail to give you as much support as possible. Let's start with the vertex form here, and I just have an index card that you can use, you can create to help follow along. And make sure you're doing every step correctly. So first of all, vertex form, the equation is y equals a x minus h squared plus k. And this is vertex form because you can pull out the vertex of your quadratic right from the form, because your vertex is hk. When we pull out the h, we actually just want the h piece. We don't want the negative with it. That's part of the formula. So when you pull out the h, it's actually going to be the opposite sign from what you see in the equation. And the k is what it is, okay? So when you pull out the h and the k, just pull out the h, don't pull out that sign with it. Once you have your h, or whatever your h is, that is your equation for the axis of symmetry. So I'm going to put AOS for axis of symmetry. Your axis of symmetry is always a vertical line because a parabola is a U that will either open up or open down. So the axis of symmetry will be a vertical line that cuts right through the parabola. So that way the left side is exactly matching the right side. It's symmetrical. So because it's a vertical line, we know the equation of any vertical line is an x equals a number, and it will always be your x equals h. It's whatever that x value is in your vertex. For your y-intercept, you always want to plug in 0 for your x and solve for your y. So we can plot on our graph, we can plot the vertex. We can kind of sketch out a dashed line for our axis of symmetry. And we can plot the y-intercept. Once we plot the y-intercept, what we can do, because a quadratic is symmetrical, however many units away we are from this y-intercept point to the line of reflection is however many units away we will be on the other side. We can reflect this point on the other side of the axis of symmetry line. And then we'll have our 3 points and we can connect the dots. So reflect the y-intercept point across the axis of symmetry for another point. The only thing that we have to keep in mind is if our y-intercept is the vertex, or if our y-intercept is not graphable, then we would have to pick another point for x to plug in and solve for our y. And the point we would want to pick for our x value would just be a point close to your h value, okay? So let's write that down. So if vertex point is the y-intercept or not graphable, I think I'm making up that word there, but if you can't graph it, then you're going to pick another point for the x and solve for your y. Okay, and you want to pick an x value that is close to the H in your vertex, okay? It's got to be close to the vertex. And then you'll have another XY coordinate to plot. And reflect. Okay. All right, so let's try a few out. So keeping in mind all of these things for vertex form. We have our first example here, -3, that's going to be our A. We have our H, but it's always the opposite sign of what we see here. So our H is going to be -1. And then our K, that's going to be 9. So our H and our K, we can plot -1, 9. Because we have a -A, we know that our graph is going to open down, which means we will have a highest point, which is a max. Also, because we know that our H is -1, my axis of symmetry is going to be x equals -1. So this will be a dashed line that we can draw in here through the x equals -1. For our y-intercept, we're going to set 0 in for our x and solve for our y. Another word for f of x is y. So we can just replace that. If that f of x is confusing you, just replace that with a y. Remember to always do what's in the parentheses first, order of operations. And then you can square. -3 times 1 is -3. -3 plus 9 gives you a 6. So my y-intercept would be 0, 6. So 0, 6 is right here. Because I am 1 unit away from the line of reflection, I'm going to be 1 unit away in the other side. And then I can connect my dots. There's my graph. All right. So you guys can work on trying out the other ones. Let's do number 4 together. Number 4 together. Again, we can identify -2 as my A. My H will be the opposite of what I see, so -7. And I don't have anything else for my K, so my K is 0. Therefore, my vertex is -7, 0. My axis of symmetry is x equals -7. And I can start to plot this. So 7, 0, -7, 0 is right there. My axis of symmetry will go through that. Okay. So for my y-intercept, I'm going to set x equal to 0. Do what's in the parentheses first. Then square. Okay. -2 times 49 gives me a -98. Here's an example. Where this is not graphable. Clearly, I'm not going to keep going to -98 here. So I need to come up with another point to graph. Here's where I would want to pick a point for my x to plug in for my x and solve for my y. So because my vertex is right here at -7, I want a point that's close to the vertex. So I can plug in -6, maybe -5, maybe -8, maybe -9. I'm going to plug somewhere an x value that's somewhere close to my vertex point. I'm going to plug that in for x, solve for my y. So let's say I'm going to use -8. Let's use -8. But again, you can pick any x value that's close to your vertex. Okay, do what's in the parentheses first. Okay, -1 squared. So -1 times -1 gives me a +1. So -2 times a +1 still gives me a -2. So my coordinate is what I plugged in for x. So my x is -8. And my y is -2. Okay, so let's plot that. -8, -2 is right here. Because this point is 1 unit away from the line of reflection, I'm going to be 1 unit away on the other side. And then I can graph. Connect the dots. Okay. All right. So just a couple things to point out on the back. Which graph represents a quadratic? So first of all, we can identify that the A is positive. So I know my graph is opening up. So I can cross out any of the ones that are opening down. The next thing I can identify is my vertex. So if I pull out my vertex, I want to just test out where those points are located, and that'll help me narrow down my answers here. Which equation best represents the graph? Again, I want to identify here my vertex is at 0, -4. So I'm looking for the equation that has the correct h and k. Remember, your h is the number that's inside the parentheses. K is your number that's outside the parentheses. Okay, so if I've got 0, -4, then I'm looking for -4 to be on the outside of the parentheses. So like this and this, and 0 to be inside of the parentheses, which really just simplifies to x squared. Okay. C and D would represent -4 inside for x. Okay. So this would be that this would be an h value. And we have our h value being 0. We don't have our h value being 4 or -4. Okay. So the ones that we're looking for, we can cancel out these, okay, because our h value is not 4 or -4, it's 0. And then our k value is -4. Now remember, our k is the sign that you see. Okay, we don't have to change it. So because our k is -4, I'm going to go with the option that has -4. Write a function that represents the parent function, y equals x squared, after has been translated 3 units up, 2 units to the right. 3 units up, 2 units to the right. So this would represent our vertex here. And we always start with our h, which would be the left or right. So we're going to start with 2. 2 to the right is a positive direction, so 2. And then 3 up is a positive direction, so 2, 3. So my vertex is 2, 3. Now remember, the h, when you plug it into the formula, it's always the opposite sign. So we're looking for a -2 inside the parentheses, okay? This is a -3. We don't want that. This is a +3. We don't want that. We want a 2 inside the parentheses, but a -2 because that's what our formula has. So this guy has the -2, and it also has the k being 3 outside of the parentheses. There we go. Which quadratic function has an axis of symmetry of x equaling 2? Well, remember, our axis of symmetry is the x value of the vertex, and we represent the x value of the vertex with the h. So we know that h equals 2. But remember, the h in the formula is the opposite sign of what we see. So even though our h is 2, in the equation, in the formula, we're looking for a -2 inside the parentheses. So -2, -2. We can narrow these down. We also have a minimum value of -4. The fact that we have a minimum must mean that our graph opens up to have a minimum value. If our graph opens up, that means our A is positive. So I'm looking for the positive A out of this. So this can be canceled. C would be our only result there. What is the y-intercept of the quadratic function? So here we would want to plug 0 in for x, solve for our y. You can do that. All right, so hopefully this clears up any questions with vertex form.